Okay, so we're back, and we saw that if we graph log of d, so the way we did that, log of d was on the x-axis, d versus log of p. Okay, if we graph that relationship, we end up with something that looks like that. And because the points line up, and they say that they're linear, therefore, we can say, well, we have a linear relationship between log p. So we have something, log p is equal to, let's call it big A, plus, what is it? N log d. Okay, so we have some linear relationship between log p and log d. And if that's the case, we can also say, well, we have a power relationship between p, and if we're saying that a is log little a, d to the n. Okay, so we have a power relationship. Okay, now I'm going to give you a set of questions here, and they're all they should work out fairly well as either a semi-log exponential function or a log-log power function. So in this case here, we know we have a power function, so we need to find the value for a using that big A, and we need to find the value for n. So if we just look at our relationship, so if I say big P is equal to big A plus n and big D being log of D, big P being log of P, big A being log of A, what is the n part? What does that make up in my relationship? What does the n give me? The n gives me the gradient. Okay? So, what's my gradient formula? If I have y equals mx plus c, x is the gradient, correct? So what's the... What did I say? X. X is not the gradient. M is the gradient. So what's my gradient formula? That's right. y2 minus y1 over x2 minus x1. So here we have a couple of points to choose from. So I'm not really strictly following this, but I'm just going to pick this as y2 and x2 and y1 and x1. Okay, now I can pick any 2 points. I could pick 2 points that were on the original one. I could have even picked Pluto if I wanted to. So I'm going to use, to find n, sort of box that in over there, and I'm going to say, well, n is going to be equal to 4.780 minus 1.944 all over 3.653 minus 1.763. So you can use any 2 points, and if I calculate that, 4.780 I get an answer which is 1.5. Oops, where did I go? So this calculation here tells me that my n value is 1.5. Now I found my n value, I'd also like my a value. So in my linear relationship, how would I find my a value? A is the what? It's going to be the y-intercept, or the p-intercept in this case. Okay? So to find my a, I could just sub in a point, couldn't I? I could just sub in a point for D and P, and I have N, and I can find A. Okay, this is Year 9 math we're doing here. So I'm going to let P equal, let's use a point we haven't used, so we're going to use this one. So I'm going to go P is 2.562, and big D is going to be 2.176. So we can say, well, therefore, 2.562 is equal to A plus N, which is 1.5 multiplied by 2.176. So A is going to be 2.562 minus, out of frame, minus 1.5 multiplied by 2.176. Just put times in there. Which is negative 0.702. That doesn't seem to work. What have I done wrong? Have I done something wrong? Oh, I know, never mind. Yep, we're all good. Okay, so this is my A value. Okay, so I've got my big A and I want my little a. Okay, so remember big A is actually the log of little a. So log, what's the base for log? 10, that's a log base 10. So then A is just going to be 10 to the power of negative 0.702. Negative 0.702, which is 0.199. Okay, so I have my value for A and my value for K, or sorry, N is here. So I can say, well, what I'm really after is my power relationship. So my original power relationship is P being equal to A D to the N, which in this case is 0.199 D to the 1.5. And we can just double check that by plugging in a point. Let's put in Pluto. So Pluto, we had this value here. So if I put in for D 5900, so I've got P is going to be, I'm off the screen, aren't I? P is going to be 0.199 by 5900 to the 1.5, which is, hopefully this will work, or otherwise that'll be embarrassing. 90,184, which is pretty close, about 90,000. So I'm within 300 days. So I'm within a year of Pluto's orbit, which is massive, by the way, but that's besides the point. Alright, and so that is a log-log example. Now, before I finish, I'm just going to point out, this is really for the video, the differences between a log-log and a semi-log. If I have a semi-log, I'm only logging one of the variables. Which variable would I be logging in this case? Anyone? It's not just the y, so only the p. So I wouldn't be doing the log d. I would only be doing this for the log p. Okay, for a semi-log. Now, what we did, the same process would be similar. Our relationship would be slightly different because we would have, we'd have k d, and we'd end up with a different sort of function. The other significant part about a semi-log is that now an exponential function, I'm going to scribble on this, an exponential function is y equals a to e to the kx. Now if I do a semilog on that, in order for that to cancel out, I need to have a ln. So if I'm doing a semilog, I need to ln both sides, which means that when I'm logging my p, I have to have log base e instead of log base 10. Okay? Yeah, I think that's fairly straightforward. Anyway, that's a log-log example, and if you've got any questions about the confusing stuff I just said at the end there, come and see me, I suppose. Alright.